All right, guys. So I just wanted to highlight a couple of interesting videos I came across on YouTube. One of them is with the Gamers Nexus that talks with the GPU engineer at Intel, Tom Petersen, and they talk about improvements to the next generation of chips that are coming out, XC2 or something like that, right? But the reason I bring it up is because in it he talks about indirect rendering, and he also talks about a BVH, bounding volume hierarchy, right? So you guys might remember that we did a whole ray tracing series talking about how these bounding volume hierarchies surround surround the spheres. So if you remember, um, in the video, right, in the video we have these spheres, right? And these spheres are procedural geometry. So it's not like real objects that we have created. It's these spheres were created mathematically, right? And then what happens is that you have these axis aligned bounding boxes, which is like a type of bounding volume hierarchy that surrounds these spheres, right, or circles. Well, spheres. So what happens is that when the rays come into the scene, um, you know, you basically just test to see if you hit a box around the sphere. If you hit a box around the sphere, then you have to run the intersection test. You have to do the mathematics to run the intersection test. If it doesn't hit a sphere, then you don't have to. You save time and effort and energy and compute on running that intersection test, right? So that was one thing that was, and we could see it here. These boxes that surround the spheres, because remember the spheres are just mathematical objects that are created in the scene. It's not like a real object or anything. So we have to test when we're doing ray tracing. We have to test whether we intersect any of those. So these boxes basically help with that. They're also called axis aligned bounding boxes. But anyway, he talked about improvements to the architecture of the chip and the processing and stuff, so that you could get better frame rates in a ray tracing scene, right? Another thing that he discussed was the indirect rendering and improvements to indirect rendering, so that basically you don't have to go back and forth to the CPU to get another draw call. You can originate the draw call from the GPU itself. In our case, in our examples, the videos that we talked about, it was basically the GPU going directly into memory and seeing what the state of the buffer was, like what the state of the data was inside of the buffer. And based on that state, it basically would follow the draw calls, or the yeah basically follow the cues inside of the buffer, the data inside of the buffer, and initiate draws or not initiate draws. It was part of a culling thing, so we would cull objects out of the scene, all of that stuff. We'll turn them off. So that was another improvement that was made at Intel for their next generation of chips, I think called XE2, their GPU chips. And you could see the graph with improving the hardware and the software for that, drastically improve the frames per second, and basically, you know, how rendering done. So again, with indirect rendering, you're not going back and forth to the CPU to get the next draw call. The GPU is implicitly drawing, from sort of its own command, and it's a really big deal. That's, once again, I'm seeing that it's a big deal because they spoke about it in this video. Another cool video from Gamers Nexus was the AIC partner or whatever, for Intel chips. So the AIC partner basically gave gave Gamers Nexus a tour of how the GPUs are built, and it's really interesting. So I'll link the two videos in the description below. But I just wanted to bring it to your attention because, of course, guys, we are GPU focused, and we are all about learning how to program the GPU, and learning these different APIs and all of that good stuff. So anyway, guys, that's it. I will link the description. I'll put the links in the description below. Thanks for watching. Like, subscribe, tell your friends. Learn whether it be Vulkan or Meadow in 2026. Take some time out to actually learn this stuff. It will be rewarding. If you want, on the Vulkan side, tutorial number one is for installing the Vulkan SDK, and tutorial number 13 is for installing a bunch of examples. But anyway, guys, thank you for watching. Have a great day.